Okay, so unit 3, notes 13. What we're going to do here is discuss function versus relation. The objective today will be able to determine if a relation is a function given a set of coordinate points, a graph, or a mapping diagram. Okay, so I'll show you what a mapping diagram is because you may or may not have seen it before. All right, so let's begin with the definitions because that's essentially what we need in order to be able to determine which one is which. All right, so if we begin with what a relation is, all right, a relation is a relationship between sets of values of the domain, which are your x values and the range, which are your y values. Right, so some of this language is a little bit familiar because last semester we spoke a lot about domain and range. And we discussed it in the sense of domain is like everything that everything that the x-axis covers, and then the range is everything that the y-axis covers, right? And so we spoke about what is the domain of a function, like absolute value, or what's the domain of a quadratic, and then we spoke about what is the range as well. So when we're discussing what a relation is just like, do I have something that includes a x value and a y value? Pretty much, right? Like if I have a point, a coordinate point, that's a relation, right? So it's anything that has both an element from the domain and an element from the range. Okay, you put those two together and you have what's called a relation. All right, and then relations can be displayed as a table, right? So like a table of values, like your X column and your Y column, right? So a table, a mapping. Okay, you'll know a little bit more about mappings later on today, or a graph, right? So an actual physical graph, and then we can use certain tests to determine whether that graph is a relation or whether it is a function. Okay, so relation is general, right? I have something from the domain, I have something from the range, I have a relation. Okay, now a function is more specific than that. Okay, because with the function, it's basically like saying I cannot have something that doubles up, right? And to give you like the best analogy is like this. You go to a soda machine, right? You want a Coke, you press the button. You expect to get a Coke out of it, right? So let's say I hit the button for Coke, I get a Coke. You go, you hit the button for Coke, you get Fanta, right? That machine is not working the way it's supposed to because the button for Coke is giving you either a Coke or a Fanta. And you don't know which one is which, right? Like which one is the one that I'm supposed to get, right? I'm supposed to get Coke, but I got Fanta on the second try. So it's not consistent, right? Like one input, which is the pressing of the button, is providing two different outputs, which would be the two different types of soda. Okay. So in that sense, that machine is working not as a function. Okay. Because here's what a function is. A function, I'll do some different color. Okay. It is a relation, right? But it's a special type of relation. A relation in which each input has a unique output. okay? A relation in which each input has a unique output, right? That's what a function is. All right. And so I'll kind of explain like ways in which you can tell, like, how do I know if it's a function? How do I know if it's a relation? All right. But those are the two different definitions. All right. So relation is general. Anything as long as I have a X value and a Y value, that's a relation. Okay. And then that could be displayed in a table. It could be in a mapping. It could show up on a graph, right? But a function needs to have one input go directly to one output. And that must be a unique output. Okay. I cannot have one input go to two different outputs. Okay. That would be a problem. Okay. Because that would no longer be a function. All right. So I know it's new, right? You're kind of getting used to what these things mean. We'll talk about them a little more as we go through the examples as well. Okay. All right. So here's our first example in box number 2. All right. So the first thing we'll do is first we'll identify. So we're going to be given a set of coordinate points. And what we're going to do first is identify which one of those numbers belongs in the domain, which one of those belongs in the range. And then ultimately, can we determine whether this is a relation or whether this is a function? Okay. So here are the instructions. Find the domain, the range, and determine if the relation is a function. Okay, and so here's the set of coordinates. All right, so my set of coordinates is going to be 5,2, -3,4. Whoa, what happened? -5,6. Oh wait, sorry. 5, -6. And then 8,0. Right, and that's my set. Okay. So we're basically given a relation, right? Because we're given this set of 4 different coordinate points. And if you notice, each one of the coordinate points has a X value and a Y value, right? So they have one from each, one from the domain, one from the range. That is enough to make it a relation, okay? We then have to look at it more carefully to see whether or not this relation is a function, okay? So most things that you're given are automatically relations, right? Anything that you're given is a relation, essentially, in all of these examples. But then it's up to us to say, okay, is it specific? Does it satisfy the definition of a function? Okay. So before we do that, right? Okay, let's first identify what belongs in the domain and then what belongs in the range. Remember that domain is where the X values live. The range is where the Y values live. Okay. So if I wanted to describe what belongs in the domain, I would look at each one of these coordinate points, right? And I could go through and I can highlight all of them with X, Y, right? Yeah. So I know that this is the X value. This one is the Y value, right? And it's the same for each point. So X, Y, and X, Y. Right? So why do I do this? I do this because then it makes it real easy to see which ones are in the domain and which ones are in the range, right? So the domain is everything that is underlined with an X, right? So in my domain, I'm going to put some curvy brackets and I'm going to list out the numbers, okay? I have 5 in my domain. I have -3 in my domain. I see 5 comes up again, right? I don't need to double up on 5, right? 5 is okay as long as it's listed once. Okay. And then I go to 8 Okay, so in the domain, in the list of the domain members, right, you don't duplicate, right? It's like if you're a member at a club, you don't need your name written there twice, right? Once your name is in part of the club, that's it. So it's just you, it's just the one person. So 5 is only written once in the domain. Okay. And then for range, it's very similar. We'll do a set, and we're going to identify all the numbers that belong to the range, right? So the range are all of the values that are Y values. So that includes 2, that includes 4, that includes -6, and that also includes 0. So the range right now is just a list of numbers that all belong, or that all are Y values and therefore belong to the range. Okay. All right. Now here's the part where we have to use, the definitions to help us identify, like, is this a relation only, or is it also a function? All right. Here's what you look for when you're going to determine if something is a function. Look at your X values. Okay. I had 5, -3, 5, and 8. That's the key. You look at the X values. All right. I have a duplicate. I have 5. It shows up twice. 5 is here, and 5 is also here. What do you notice the first time we see 5? What is the output? It's 2, right? But then you see 5 again, and then this time, what's the output? Then you have -6, right? So the first time we see 5 is here. You input 5, you get 2 out, right? Think of it as a machine, right? You put 5 in, you got 2 out. You put 5 again, you probably expect 2 again, right? But this time, what do you get? You got -6. So this is like a girlfriend with 2 boyfriends, because, 5 is not doing something right, right? I'm just kidding. That was probably a bad joke. But anyway, think about it like that. All right. It's an easy way to remember. That one number has 2 different outputs. The first time it's 6. I'm sorry. The first time it's 2. The second time it's -6. And that's not good, because that means not a function, not a function, not a function. Okay. So when you see something like that, right, this is what we say. Okay. So the relation is not a function. Because, and this part is important, okay, the way we write it, I think I took it from Sosa. I remember her saying something like this. And I was like, that's kind of controversial. Like, I don't know if I should use that. But, I think it's like empowering. Like, the girls have all the options, like the girls get to pick. Ultimately, the girls pick, right? So the relation is not a function because, right, is not a function because the input 5, okay, has 2 different outputs. Two and -6. Okay. That is how you answer the question. Okay. So the relation is not a function because we had a certain input, which was 5, that generated 2 different outputs. So then we can't trust that function, right? We cannot trust that machine, because when we put in 5 the first time, we got one number, then we put 5 in again and we got a separate number. So how do we know which one is the one it's supposed to be? Does that make sense? So you think of a function as like a machine that works properly every time. Okay. Are there any questions about that so far? Okay. All right. So it's only a problem when X repeats, right? When the X repeats and you get different Y values. Okay. Now, if we would have gotten 5, 2, and then 5, 2 shows up again somewhere else, that's not a problem because every time we put in 5, we're getting 2. So that machine is working properly, right? Then that would have been a function. But in this case, because the machine is not working properly, it's not a function. All right. Okay. Hopefully we kind of get the hang of it. So there can be duplicates, okay? So let's say you would have had 5, 2, and then 5, 2 shows up again, right? The duplicate is fine because the input was 5 and the output was 2 both times. That means that the machine is consistent, right? The machine is providing the same output every time you put in that input. But if you put the same input and you're getting different outputs, then that's when the duplicates can be a problem. Okay, so I think I have an example where that kind of pops up a little bit later. Okay. But don't worry, we'll continue to practice. All right, so that's what we call like the ordered pairs, right? So here I gave you a set of ordered pairs, X, Y, and then we were able to determine this is domain, this is range. Here's how we know that it's not a function, all right? Because we identified the one input that provided 2 outputs. Okay, let's take a look at a table. Let's see if we can identify it from a table only. Let's say, would it be the same if it was on the Y? So if you mean that, I think I know what you mean, that like the Y value shows up multiple times, that's okay. The only time it's an issue is when the X value repeats and it goes to separate outputs, right? So like 5 comes in and we don't know whether to go to 2 or to -6. That's a problem, okay? But if it's like 5 goes to 2 and then 7 goes to 2, that's okay, right? Because the X, the input did not repeat and it didn't go to separate values. And I'll show you what I mean because it comes up, okay? So let's take a look at a table. All right, we have X and we have Y. Here are my X values. I have 7, 2, 0, -4, right? And then my Y values this time, oh wait, do I have the colors mixed up? Yeah, I do, sorry. Okay, sorry, let me do that one more time. So the domain values, this would be 7, 2, 0, -4. All of these are X values. And then for Y, what we have is -8, 3, 1, and 3. Okay, and I think this is what you're talking about, Nelson. All right, so first, let's do what we did before. Let's go ahead and identify what is domain, right? And I've already kind of organized it by color. So in my domain, what numbers should be listed? Inside of the set. Yeah, we just want 7, 2, 0, -4, right? And the order doesn't particularly matter. Okay, so they don't have to be from least to greatest. Just stick the numbers in there as part of the set. All right, now for the range, okay, what numbers would be listed as part of the range? Yeah, good. And you didn't repeat. I like that, Ashley. So it's just -8, 3, and 1, right? Remember, once you're part of the VIP list, you don't need to be on there twice. So it's like 3 is it shows up twice on the table, but we don't need to list it twice. All right. Okay, and then the question becomes, is this relation a function, right? Is the relation a function? So you might be thinking like, okay, do I focus on X? Do I focus on Y? You always focus on X, all right? Focus on the X values. Do you see any repeats there? Okay, no repeats, no problem. Automatically will be a function. Okay, automatically a function when there are no repeated X values. okay? So remember that. If you look at your X values and there's no repeats, no problem. It's a function, okay? Why is that? Well, 7 only goes to -8, and there's no other 7 anywhere else. So then there's no way for 7 to duplicate and go to a different output, right? The fact that you're a function means that each input only has one output. Okay, it only has one output. Right. So you look at the domain first. Now, if there were repeats in the domain, right, we repeat 7, then we got to check to see, okay, does it go to the same output or does it go to a different output? Right. So right now, what we have is a function, right? Here's when it would turn into a relation, right? Or here's a situation where it would be a relation. Let's say I had 7 come up again. But this time I have, now I have this. Where does the problem exist? It exists here. The fact that 7 is showing up twice as an input, but every time we plug in 7 into this machine, we're getting different results, right? And that's what we cannot have if we want a function. Okay. Unless, correct, right? So the way I have it right now, this would be a relation because 7 does not have the same output. But if I would have done this is still a function. And you might be wondering like, well, why? Well, notice 7 only goes to -8. It's a function that if you repeat it, will give you the same output. It's a machine that's working, right? At least it's being consistent. Right? Every time I plug in 7, I'm getting -8 out. And that's okay, right? As long as it only goes to that one number, right? When 7 goes in, it can only go to one number for it to be a function, right? 2 goes in, we only get 3. 0 goes in, we only get 1. -4 goes in, we only get 3. So do we care about the Y value? Not really, okay? The Y value is only important if you see a repeated input. But you always look at what are my X values, okay? So in this case, if we go back to what the original table was, in this case, no repeated X values. So automatically, this is a function, okay? And what do we say? Well, just like before, we had to give an explanation as to why the other one was a relation. This time we have to say why this is a function, okay? And this is the reasoning that we give. So the relation is a function. Okay, because, and this is key, all right? Each input has a unique output. Okay, each input has a unique output. Yeah, so so saying that there's no duplicates does not satisfy the definition. I'm trying to use the definition of a function to give you the reason why, right? So I need this specific answer. When you answer whether this is a relation or a function, I need you to use this wording. Okay, don't try to like give me a simplified version. This is what I need to see, that it's a relation. I'm sorry, that the relation is a function because each input has a unique output. Okay, 7 only gives me -8. It is unique in that sense that it only gives me that one number out. Okay, even if it repeats, right? That's why I don't like using those words like repeats and duplicates. Okay, but if 7 goes to -8, that is a unique connection, right? And it can happen again down on the table somewhere. That's fine. But it's literally like the same point. Imagine you're plotting this point, 7, -8. And then you have to go and you see it somewhere else on the table. What are you going to do? You're going to go back and you're going to fill it in on the same dot. So it's not a different dot, right? It's the same dot. Shows up twice. But what it does on the table is that it tells us that it is a consistent consistent machine. Therefore, it is a function. So mathematically, right, you have to say that each input has a unique output. Nelson, let's see. It says, well, what if there is two coordinates such as 7, 8 and 7, 8? Well, if I had, do you mean on top of the fact that I already have 7, negative 8? Like if I had another, like if I had this, then I'm not sure if I understand your question. Well, okay, so okay, so like let's say if I had 7, negative 8, and then downward on the table somewhere, I have 7, 8. Well, obviously the 7 is giving me different outputs, right? One, it's giving me negative 8, the other one is giving me positive 8. So this right here, if I'm talking about this scenario right now, this would be a relation because 7, the input 7 gives me two different outputs. Okay. Now, if it just showed up again, this still right here still represents a function because 7 only goes to negative 8. Okay, so even though it shows up twice on the table, the connection between 7 and negative 8 is unique, right? 7 only goes to that output. 7 only goes to that output, even if it shows up twice. All right, that's what I'm trying to say. Let's see, Hazel, basically, y does not matter, but if the same input gives another output, then it's a problem. Yes, yeah. So you don't even look at y until you see a duplicate x. So if there are no duplicate x's, it's automatically a function. Kind of, exactly, right? If it shows up twice, it's like a different person just getting the same soda, right? But the machine worked. You hit the 7, you got negative 8. Somebody else comes, they hit 7, they get negative 8. That machine is working, therefore it is a function. But if someone came and hit 7 and they got like 12, well then that's no good, right? Like the machine is not consistent. All right. Or think of 7 as like, all right, here's a relationship, right? Like a guy with a certain girl, 10 months go by, guy, same girl, right? Think about it like that, right? So that's unique, right? That relationship between 7 and negative 8, that is a unique pair right there. All right, so let me erase this. Okay, how are we doing so far with like understanding relation and function? So far, so good. Okay, so it's not too bad, right? It's not too bad. Okay, let's continue, right? So we saw coordinate pair, then we saw table. Now let's take a look at mapping, right? Let's look at the mapping. Mapping is literally like drawing an arrow from one number to the other, right? Like you map your direction, kind of. Okay, so it's not anything like incredibly new. You may have seen it in like a textbook um, at some point in your life, probably. So mapping kind of works out like this, right? So you kind of have like your X values in a bubble. It's like a long oval. And let's say you have these 4 values as part of your X values. Yeah, you draw it. Yeah, because the mapping will look like this. It's like a circle with some numbers inside. And then you have the other set, which would be the Y values. And then they're inside of another bubble. And you have -4, 0, and 7. All right. Okay, so then here's how the mapping works. The mapping is something that will be given to you already. So the arrows that I'm drawing, it's because this is how the example looks like. Okay, so it's not that I'm doing this randomly. This is just how the example is. Okay, so what you will see typically when it gets like printed on paper on like or on a question, it'll already be done. All right, so I'm gonna draw it out how it is on the example. All right. So this is the mapping, right? This is the mapping. Now, when you see the mapping, sometimes the lines are a little tricky to follow, right? And you're kind of like unsure, but just by looking at it, whether if I'm looking at a function or a relation. Okay, so here's what I like to do. I like to take the mapping, convert it to coordinates, all right? Because that's literally what it is. It's just coordinates hidden in a kind of diagram format. All right. So if I look at this and I start with my X, right? My X value. So if I'm creating a coordinate, the first one I see is 2, and 2 connects with 7. So I have a coordinate that's 2 comma 7. All right. So 2 goes into the machine, 7 comes out. The next one would be 8, right? So I start now coordinate 0.8 and it ends at 0. So when you put 8 into the machine, you get 0 as an output. Good, Nelson. Keep that thought. All right. So then the next one, 13, that one goes to -4. And then the last one, 17, that one goes to 7. Okay. So remember what I asked you to look at, right? What is it that you look for first? Do you look for Y values or you look for X values? You look at your domain, right? You look at your X values, right? So now that you have them listed as coordinates, look, you have 2, 8, 13, and 17. You know that those are the domain values, right? So if we had a list domain, that's easy, right? We open up the set, 2, 8, 13, 17. Voila, right? We list the range. Those are the Y values, right? So although we have a repeat 7, right? You're on the VIP list once, you don't need to be on there twice. So then it's just 7, 0, and -4. Okay. And then somebody said something pretty good to me here on the chat, but it was a direct message. So why don't you go ahead and just type that out for the whole class to read? What do you notice? Yes, you. Okay, so it's a function because none of the X values repeat, although there is a double for the Y value, right? So I like that you said that because you were focused only on the X values to determine whether this was going to end up being a relation, right? But the fact that there were no repeated X values automatically tells you this is a function, all right? So this is like when you go to a soda machine and they have like 2 different buttons for Pepsi, right? I don't know why they put 2 separate buttons for Pepsi, but there's 2, right? And it's the same Pepsi can, right? So that's kind of what happens, right? You plug in 2, you get 7 out, right? That's that first button for Pepsi, okay? There's another button for Pepsi on the machine, and you hit that one, and it also gives you Pepsi, right? So both of those buttons seem to be working, right? So that's kind of what's happening with when you input 2 and you get 7, and then you input 17 and you also get 7. That's okay. You know what that's called? That's like a quadratic sometimes, right? Think of a quadratic, U shape, right? So sometimes you'll be here on the x-axis and you go up to like 16, and sometimes you'll be over here on the x-axis and you also go up to 16, right? So quadratics tend to have that pattern sometimes. So, but those are still functions, and we'll talk about those a little bit later. But for now, my x values do not repeat. Therefore, I have that each input has a unique output. All right. Each input has a unique output. So the relation is a function because each input has a unique output. Any questions on that one so far? So again, this is what we call a mapping or mapping diagram. That's what we mean. Okay. Let me show you a mapping that shows a relation. Okay, real quick. This is just extra. Okay. The bottom one is a relation. Which one is the problem? Yeah, 5 is the problem, right? Because what is 5 doing? It has 2 different outputs, exactly, right? It doubled up, right? I'm trying to think of what Nelson's trying to say, right? It doubled up in terms of like it went to 2 and it went to 1, right? And that's not right. We can't have that if we want to function. There's a relation, that's okay, but 5 was the problem, right? Even though 3 went to 1 and 7 went to 1, you guys are noticing that the problem begins with X. So when X is going in 2 different directions, that's the problem, okay? So here, this scenario is a relation only, not a function, okay? It's a relation. The input 5 has 2 different outputs. I should put the word 2. Which are 2 and 1. Okay, and I show you that one because sometimes some of you need to see like, well, if this is the function, well, show me the relation, right? So I wanted to show you both so that you know which one is showing a function and then which one is showing a relation. And that's the difference. When 2 values lead to 0, does that still consider it a function or relation? Because 0 basically has no value. You still have to treat 0 like a specific number. 0 has no value, but 0 is a number. It's a specific output. Okay. Any other questions so far? All right, we got about 13 more minutes. I want to get through the last one. The last way to test something for a function or relation is the vertical line test. And this one tends to be like everybody's favorite because it like makes it very easy to see visually, right? And you've probably heard or done vertical line tests before, so this is probably a little bit of review. Okay. So these are kind of like the analog ways, right? When you don't have a graph, right? When you're given, let's say, a set of points or a mapping or a table, the whole point is that you know how to identify it without graphing it, okay? Because sometimes, a lot of times what happens is like you get these points and you're like, okay, let me graph it and then let me test it with vertical line test. Yes, that's okay, but I want you to be able to do it in more ways than one. So if I'm giving you coordinates or I'm giving you a table or I'm giving you a mapping, I want you to be able to identify it in the form that it's in. If I give you a graph, then I want you to identify it using vertical line test. Okay, so vertical line test is only when you are given the graph already. Okay, if you're given anything else, you're supposed to be able to identify it in a different way. Okay, but I've seen it happen a lot where it's like anything you get, you turn it into a graph and then you use vertical line test. And it's like, okay, it's not wrong, but it's like a one way of thinking only, right? So you want to think about it in multiple ways. All right, but here is vertical line test. All right. So here's another definition. Okay, so vertical line test. All right, and what it is, it's a test to determine Yeah, this would go in your fifth box. Yeah, that's right. A test to determine if a curve graph, or sometimes you'll just get a bunch of coordinate points all over the coordinate plane. Okay. Is a function or not. All right, and here's how you know, okay? So if any vertical line, okay, which means that you can draw any vertical line anywhere, okay? If any vertical line intersects the graph only at one point, then that's a function. Okay, so that means you draw a vertical line anywhere, any vertical line, okay? And if it's only gonna hit the graph at one point, that's a function, okay? But then there's the alternate of that, right? If any vertical line intersects the graph at more than one point, then this is not a function. And it's just a relation, right? So it just keeps its relation status, but we cannot call it a function. Okay, so that's the definition, and then this is how we determine whether we can call it a function or call it not a function. All right. How many of you guys remember vertical line tests, or you remember at least learning it at some point? Yeah, yeah. It's easy, right? It's nice and easy. This is a little bit of a review. Okay. All right. So I'm going to give you a coordinate plane. All right. These things are already graphed. All right. So this is what I mean about like, how would you see it? You would see it at like a graph, right? With a bunch of points, or you might see it like as a curve, right? So it just depends. All right. So this is the example here in box number 6. Let me go ahead and draw it out. Wait, that's too big. Okay, so what is this? Example 1, 2, 3, 4. Yeah, please draw it. All right, so I'm gonna draw in the points and I'll label them. Okay, so you have a point here at 0, 4. You have a point at 2, -1. You have a point at, this would be 4, -4. You have a point here at -3, 1. And you have another point at -3, -2. Okay, so why am I giving you just a bunch of points? Because this is one example of what you might get. Other times you might get the full curve drawn through. I'm giving you the points because one of the common mistakes is that what I've seen before is like you see the page with a bunch of points and then you try to connect the points somehow. but you have no idea how these points are supposed to be connected, right? We have no idea. It could be a bunch of straight lines. It could be one smooth curve. It could be piecewise, right? Like we don't know. So if you're just given a bunch of points, you do not connect them. Just leave them alone, right? The points are what they are, all right? But your job is to try to find, okay, is there a vertical line somewhere that if I were to draw it would hit 2 points on the same vertical line? And if you can identify that, then that tells you whether this is going to be a function or not a function. All right, so just kind of visually look at it. Do you see a location where if you drew a vertical line, you would hit multiple points at the same time, where it would intersect 2 points at the same time? Yeah, it looks like over at -3. Okay, now I'm talking vertical line, so the line has to be like straight up and down. So at 2, -1 and 4, -4, like that would have to be a line with a slope on it, right? But I'm talking just like draw a straight line, right? So the only place that I see that creating a problem is if I were to draw a straight line. Let me get the right color here. If I were to draw a line right here, right? That's okay. Right? So you see that like at that particular location, if I draw a vertical line, I'm hitting 2 points, right? And what else do you notice? Look at the coordinates. -3 is the input. And what do you notice about the outputs? They have different outputs, exactly, right? So imagine like you created a mapping. -3 first goes to 1, and then -3 goes to -2. -3 is going to 2 different outputs, right? And why does that create a problem? Now we see it visually, right? This is the problem, is that, well, if I go through on that vertical line test, well, I don't know which one I'm supposed to honor, right? Like, do I honor that the input, I'm sorry, do I honor that the output is 1, or do I honor that the output is -2? Like, I don't know, right? And so this is what we would consider like something that's not a function. Okay, so this one is not a function. When you use vertical line tests, the reasoning is because it fails the vertical line test. Okay, if it were to pass the vertical line test, then the vertical line test would only hit every point only one time. Okay, so here's what we can say: not a function. Right, fails VLT. All right, save you some time, because VLT just means vertical line test, so you don't have to write out the whole thing. Okay, so it fails the VLT, right? If you wanted to even be like even more outstanding, you could also say that the input, this is how I know that you truly understand this, right? If you can give me something like this, that the input -3 gives 2 different outputs. One and -2, right? That's how I know you truly get it, because you're looking at it not only as a graphical test, right? The vertical line test, but you're also looking at it as input versus output. Input has 2 different outputs, therefore that's not a function, that has to be a relation. Okay. And then real quick, the last thing we would do is just, I would probably ask you like, list the domain. What are the elements that belong to the domain? List what belongs in the range, right? So if you were to look at these points, okay, what would go in the domain? Remember that domain is just X values. Yeah, you would just list all your X values, right? So if you had to, you could go back here and just list everything that's X value. Just say, okay, that's an X, 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 right? And then you just list them, right? So that's pretty easy. Where's my green? What happened? So this would be -3. 0, 2, and 4, right? Those are my domain values, okay, or elements that belong to the domain. And then as far as the range, and just look at your y values, right? So y value here, I have a 1, -2, 4, -1 again, -4. All right, so again, you don't repeat them, list them. Sorry, I got the colors all mixed up. My fault. Let me, that's okay. All right, so range, remember, is just the y values. So we have 1, I could do -2, 4, -1, and -4. And those would be the elements that belong to the range, okay? Because those are the only y values that we have. Do we have homework today? Yeah, you just have an iExcel. You have an iExcel. I was thinking that I was going to be able to get through these notes like faster, but I didn't. So there's a classwork that we'll do like maybe beginning of next class period. So I'll put you guys in like breakout groups. And then you guys can work on it together, talk to each other. I'll give you like 15 minutes to get it done. It's pretty quick, but we can kind of use it as like a group, like a partner warm up kind of thing. So we'll do that when we begin class on Thursday to give you some time to just work and like settle this idea of relation and domain. Okay, so let me go ahead and finish this off. So I'm gonna go ahead and stop